But I think that as models are being used increasingly in kind of higher stakes settings and, medical diagnosis, legal nonprofits are increasingly rolling out chatbots to try to give legal advice. These are all domains where there is a kind of world model that we want the models to understand. And I think here we sort of need to get beyond to where we are now. And I guess my perspective is that, one place to start is work on defining what it means to have a world model, like create metrics. And once we have metrics in place, we can make models that are tailored and optimized against those and whatever we've been doing so far.
Hello, and welcome back to Tomato Tomato. I'm your host, Talia Sherman, as always, and I'm very excited today to bring you this conversation with Keyon Vafa, a postdoctoral fellow in the Data Science Initiative at Harvard. Throughout this episode, there are two strong elements worth noting. First, prescriptivism, and second, interdisciplinarity. Keyon is thinking about how research should be done and why. What methods ought we to use? What questions should we be asking? How should models be deployed, and why should the public interact with them? But Keyon's research agenda will effectively render inadequate a strictly disciplinary approach. And notice how the prescriptive questions guiding his research aren't disciplinarily directed. He wants the best outcome, for models to be accurate, to be safe, useful, functional, to show us something about our world, and have our world show us something about them. These two threads are going to carry us through some discussion and debate on Keyon's research regarding world models and AI, machine learning methods and the gender wage gap, and how studying AI and studying humans is a mutually elucidating process. In the end, Keyon will draw an analogy between documentary filmmaking and research. As always, what a blast to interview such nerdy, enthusiastic people. So please enjoy this especially method-centric, fast-paced conversation with Keyon Vafa. Keyon Vafa, thank you so much for coming on Tomato Tomato. Welcome, and I'm so happy to have you here.
Thank you for having me. I'm excited to be here.
Great. Okay, so please introduce yourself. Who are you? What do you do? What's going on? You're a postdoc in data science at Harvard in the Data Science Initiative. I will say that. But your PhD is in computer science, and you work with a lot of economists. So what's going on there?
Yeah, I mean, that's a pretty good summary of what I've been lucky to work on and do. Like you said, I am a postdoc at Harvard. Before that, I started out as an undergrad at Harvard. I did computer science and stats. And I was really excited about problems in the intersection of the two. I was also interested in kind of applied problems in the social sciences. So during my PhD, which, like I said, I did in CS, I was at Columbia. I was working with Dave Bly, a fantastic advisor. I was really able to explore really different areas, from natural language processing to these Bayesian deep learning models, to applications in political science and labor economics. So I sort of did this kind of potpourri of topics that I thought were all kind of pretty exciting. And most recently, I've been kind of expanding on some of those directions in my postdoc, which has been with the Harvard Data Science Initiative. And here I've been working really at questions at the intersection of, AI, LLMs, and human use, human understanding, trying to work on questions about interpretability. How can we make sense of these models? Do these models make sense of us? How can we use them to help us answer social science questions? And I think it's a really exciting time for all of these things right now.
Okay. I agree it's a very exciting time. Can you get a little more granular about the methods you're using and why these are helpful for scientific questions? So you're working with, exactly, LLMs, causal inference, machine learning, but these are different things and they intersect and they yield different results and they're able to be combined in relatively beneficial ways. So can you just get a little bit more specific about the methods you're using and then the questions you're asking?
Yeah, great. Okay, so I'll start with sort of one question that, I've been spending a lot of time with thinking about for really LLMs, but also generative models in AI in particular, which is, if you look at models like LLMs, they're trained to make very accurate predictions, like predict the next word of a sentence. But when we sit down and use them for things, it seems like they can do a lot more. Like the same model can, write poems about proofs. It can help me code. It can answer really arcane questions that I throw at it. And so as a field, we're really trying to make sense of why LLMs can do this. And one theory is that they have what people are calling world models, that somehow in predicting what the next word of a sentence is, they have to form some kind of structured representation about the world. Like maybe if a model is trained on news articles or like everything that about the real world, every piece of text it's trained on should obey the law of physics. And then so the argument is that, for example, in physics, that if a model is able to accurately predict what's going on, it must have embedded some kind of model of physics, as one example. So something that I've been working on is trying to say, okay, how would we test this? What would it mean to have a good implicit world model? How would we tell if models could do this? So one example that I think is illustrated that I've worked on with some wonderful collaborators was we took a model, a transformer, which is like the same kind of neural network that underpins language models, and we essentially fed it a bunch of Google Maps turn-by-turn directions of taxi rides in Manhattan. So the model would just, it hasn't seen anything except for just turn-by-turn directions. Like if you want to get from Times Square to Central Park, go 8 blocks north and then 3 blocks east and then 2 blocks north, those sort of things. So we trained it like you would train a language model so that it got very, very good at predicting the next direction, or really the next word of each direction from what it had seen so far. And when we did that, we found that the model looked very, very good. That when we gave it examples of routes it hadn't seen before, like we said, if we want to get from, Washington Square Park to, the seaport, how would we get there? It would give 99% of the time the inaccurate set of turn-by-turn directions that would get you there. And then so the question is, had this thing built like a world model? Had it kind of discovered the map of Manhattan, even though it was just trained on essentially text containing turn-by-turn directions? Or was it using these kinds of heuristics and these sort of piecemeal rules that happen to all work? And I think the reason to sort of care about this, for one, is for robustness. If we want these models to be useful in the real world, we want them to sort of have a good understanding of the structure and the rules of their domains. And another is scientific discovery. If, as we are increasingly using models for scientific purposes, we're trying to use these models to learn new things about the real world, we want to make sure the things that they've learned about the real world are actually useful ones, or at least ones that we can make sense of. So that's the question that we set up. And I'm happy to go into the details, but long story short, we worked on methods that tried to test how structurally sound its implicit map of Manhattan was, and we found that it was very nonsensical. That for example, there wasn't just one kind of Times Square intersection. There were thousands of different Times Squares depending on how you got there, and each had a slightly different set of rules. And it did well on the turn-by-turn directions because it sort of patched things up well enough that it could get you from places most of the time. But really the 1% or whatever time it made errors revealed that it really wasn't structurally sound. And as a consequence, when we slightly changed the task, like when we added detours, we prevented the model from taking certain turns and forced it to take other turns, its navigation performance really, really plummeted from 99%, down to 10.5%.
Okay. And so to make this kind of intuitive for people, the way that I'm thinking about this is it's the same thing for what ChatGPT is doing. The question is did it discover language? Does it know what to say when you put in a prompt that it's never seen before just because it knows language? Or is it doing some kind of heuristic-based thing? Because at the end of the day, you're treating taxi rides, language, genome sequences, whatever, as having a stochastic ontology. They are the same in this way where it's predictable. You're looking at, probability distributions and predictability. And then you're thinking about right, so you said it kind of has this incoherent world model when you look at the implicit world model. So in one of your papers, you talked about how it has this incoherent world model, and that leads to fragility. So what is fragility, right, in this context? But then also, are we just to take fragility as a kind of trade-off and then just move on? Is that what the project is?
Yeah, great question. So I guess to the first point, yeah, I think this is in some ways a very, very simplified metaphor for language LLMs. This is in CS, there's sort of this this very long and rich history of taking very complex problems and reducing them to model systems. So computer vision. This was a field that was really interested in trying to say, can we train machines that can see? This is a very, hard problem to define, but a way that they made progress was by creating this challenge, this, ImageNet challenge that contained a bunch of object classification tasks, a very large data set. And making progress on that, which was, obviously a much sort of smaller scale thing than what it actually means to see, could help us, see and build what would work there would help us in the bigger sense. So this is very much in the spirit of that. This is, kind of like the fruit fly of world models, where we would want to know if a model that's been trained on language has learned the rules of language, learned all these, things about human behavior, physics, all these things that we can't really write down. And so the reason that we found the taxi example really exciting was that it is kind of a simplest instantiation of this problem that we're interested in. And I think working on that also helped us come up with generalizable procedures that we could use across things as well. And so to your second question about, where do we go from here? Do we just accept the fragility? I think it's a fantastic question. I think in some places, maybe we can't accept fragility. I think that a model doesn't have to be perfect all the time to be useful. AlphaFold is a great example of this. It makes errors that are sort of obvious, apparent errors to many scientists. And that people would say that doesn't really have a good world model, but it has clearly been useful because we have a sort of sense of, this is a somewhat reliable but not 100% reliable predictor, and we can still use it in some ways. So in some cases, absolutely, we don't need the model to be perfect. But I think that as models are being used increasingly in kind of higher stake settings, in medical diagnosis, legal nonprofits are increasingly rolling out chatbots to try to give legal advice. These are all domains where there is a kind of world model that we want the models to understand. The law, that's a world model we want the model to have. The rules of medicine, that's another one. And I think here we sort of need to get beyond to where we are now. And I guess my perspective is that, one place to start is work on defining what it means to have a world model, create metrics. And once we have metrics in place that are different from prediction, that are trying to capture more of this kind of fragility and coherence, we can make models that are tailored and optimized against those and whatever we've been doing so far.
Great. Okay. So this was many years ago, but you presented at least a paper 6 years ago on your work on Senate speeches, and you were looking at textual indicators to think about ideology. And this was really interesting to me because this is the same thing that happens all the time in linguistics. Democrats say Iraq and Republicans say Iraq and, Iran, Iran, and it's completely stratified along these party lines. You were again doing this thing where you're just trying to get the implicit world model. So you're training the transformer on Senate speech data, and then thinking about the words that people use when they're talking about a particular issue. So abortion or healthcare, things like that. Can you talk a little bit about this being a little bit, frankly, just a little bit more of a realm where bias creeps in? Because I understand it's you can really, there's an objective city of Manhattan that you can compare to the model that the transformer has. But I'm not as convinced that there's this objective spectrum of ideology, or what we would necessarily learn from that objective spectrum of ideology, given whatever the results were from that study.
Yeah, great question. So it's funny you bring this up because like you said, this was 6 years ago. So I definitely wasn't thinking it. No, it's good because I was not thinking of it in terms of world model. World model was not a phrase in my vocabulary, but I've gone back and thought about it, and you can retrofit it in terms of similar questions you have, which is and it brings up a great point, which is map of Manhattan. I've worked on another world model project where we wanted to see if foundation models trained on trajectories of orbits, if they've learned the laws of physics. These are very, very nice domains for testing world models because there's the truth. I can write down the map of Manhattan, I can write down Newtonian mechanics and be reasonably confident that those are right. And that's great. But I think a challenge is that the social sciences and many other fields, unlike things like physics, are not R squared equals 1 disciplines. And what I mean by that is, R squared is kind of a metric that says, the way to think about it is how much of the world do your theories explain? So, it's very high for physics in terms of at least, Newtonian mechanics. It's very high for map of Manhattan because, we've built that theory. Whereas in the social sciences, you'd be lucky to see R squareds of 0.2, 0.3. It's a number between 0 and 1 for perfect prediction. And so this is one of the challenges, which is if we have these sort of, uncertain world models, we want our models to be, the reason that we're training things like transformers to recover them is because we don't have that much confidence in them to begin with. But how do you validate something that you don't have that much confidence to begin with? Like, this is like a really, really hard problem. And so like I think that this is like, a lot of people are working on things like this. So what we did in the like Senate speeches was like this project was sort of based on the idea that there had been a lot of work that looks at how senators vote and uses their voting patterns to try to see, who is more in one direction and who's more in another direction. This is called an ideal point. It's essentially a numerical summary that captures someone's political preferences. So like, Bernie Sanders would be very much in one direction, and a very right-wing senator would be, very much in the other direction. And people like Joe Manchin would sort of be like right in the middle. And so we were interested in doing this for text. And the problem is that like in just using the method that people typically use for votes and just applying it to text is very hard, because text it's what we call high dimensional, that there's not just like one vote on a topic. It's when I am giving a speech about something, I'm using a bunch of words, and a bunch of these words are also used by other people, but maybe in slightly different contexts. And so the challenge that we were interested in was saying, how would we just use text, not use any like party information, like we don't know who's a Republican, who's a Democrat, just like text to get these political preferences. And so we had a method that like looked good to us, and that was nice. And the way that we validated it, or we tried to validate it, was we compared how close they were to the voting based ideal points. But like you said, this is sort of a challenging thing, because there is no like, ground truth way that someone speaks. We're just positing a model, and we're seeing how well that this model captures other things that we can also make sense of. But at some point, you need to start making assumptions, or else this becomes kind of untenable.
Great. Okay, so thank you for that. I think that leads me, though, to kind of ask about what do you think that this science is really for a lot of the time? Because it seems to me like in a lot of social sciences and in hard sciences, it's like, okay, we're going to put trust in this model to tell us about our object of study, because we're kind of done figuring out our object of study based on the like paradigms that we've inherited, because they're not good enough, right? So like, I don't want to care anymore about figuring out what a word is. I'm going to trust in LLMs to tell me what a word is, and just think about tokens or something like that, because like that's a debate in linguistics of what a word is or something. And I'm not going to think about who's a Democrat and who's a Republican. I'm just going to think about these textual indicators to give me ideology around abortion. And like maybe that would tell us more about, and like, I don't know, like maybe people would have voted differently in 2020 if they'd seen your research about this, because they would have said, oh, great, Roe is going to be overturned anyway. Susan Collins is going to vote for Brett Kavanaugh, like blah, 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 blah. I guess she had already voted for Brett Kavanaugh at that point. But like, maybe this is going to change minds. I don't know. But like, I think this gets to the thing of like what this science is really for, because you're very conscious of utility across all your domains of research, including, human AI interaction, all these different things. So I'm curious about the utility, functionality as well, because it seems like you want this research to be useful, but it's like, for what?
Yeah, that's a great question. I think like, so at the most like broadest level, like I guess the thing that motivates, I think, all these projects are just like thinking about the people who would be either using them or would be getting insight from them in some way or another. So like, something that I think is interesting is, not only stopping a analysis when we see, how good is an LLM at predicting the next word on average, but trying to really model how a human user would do at that. Like, if a human is using an LLM to make decisions, how does that actually affect their decision making? Or if a human is using an AI image generation model not to make realistic looking pictures, but because they want one that looks like the specific thing that they wanted, how would we be able to measure, and how would we be able to test that? So I guess like this is kind of like a very, vague response, but like I think that to me, the questions that are most interesting are not ones where, it's just a single number that's kind of hard to interpret, or there's like, one like kind of summary statistic. But like, I really like try to think about like, what is the insight here or the result here that would either a human using something that I've built or a human like reading this result can make sense of, and, hopefully either think about how they can make changes to their daily life based on it, or we can change how models are built and being designed for that human in mind. So yeah, I don't know if that's like if that was what you were looking for.
Yeah, no, I mean, I guess like I want to know, maybe, thank you for that. No, that was a great answer. I'm curious also about the interdisciplinary perspective. This is something that I was like obviously fascinated. Well, I think that's like probably one of the main reasons I wanted to have you on the podcast was for the interdisciplinary perspective, because it kind of does amaze me that you're doing all this economics research with economists, but you have very different like skill sets. And then it seems to me like the objects of study can get more and more diverse under one methodological umbrella right now. Like in the social sciences, like if we move towards these like neural network models, stochastic models, the object of study can just like expand and be anything. Like it can be genome sequences. It can be people say on the house floor, like it can be anything. And that kind of like problematizes disciplines themselves because they're generally carved up by object of study rather than method. But like it's the methodological turn, maybe, okay, fine, it could be. But then, do you think this is like, I guess, yeah, do you think this is an interdisciplinary thing, or do you think this is really just like a methodological turn?
Do I think what is an interdisciplinary thing?
This research that it can encompass, that it's kind of like this like object neutral approach. Like you're just developing methods and then thinking about like the implications of that and then tweaking it slightly depending on the object of study, but like not really, because whether it's a textual indicator that's actually like a phonological indicator or a textual indicator that's really like a taxi cab steering wheel indicator, it's the same thing to the model.
Yeah. Okay. I want to make. I think I understand, but I may not. So correct me if I'm not understanding the question. I guess like to the point about like interdisciplinariness. I guess this is where I'll start. I do think like increasingly, like as everyone's using AI and like we can't escape it and it's all over the news and stuff.
Yeah.
Like my view is that like there's not one discipline or set of ideas that can be used to answer the questions that we want, or even to ask the questions that we want. And I think like a lot of the kind of like in some ways there's been immense growth in AI, and this is not in some ways, in many ways there's been immense growth in AI. But otherwise, if you look at like the research coming out of academic labs, I think a lot of groups and people have sort of asked themselves like what are the interesting questions that are worth studying now. It's like it's a very different world than it was 5-6 years ago in terms of what interesting research is. And like from my perspective, it's the really interesting thing about this time period about like machine learning and AI is just that it's touching everything. It's touching, like science, touching people. And so I think that like my perspective is that we just can't study any of these things in isolation, and we can't just study them just in terms of like, general methods without thinking about an application. So how I think about research is I always start by thinking about what is the like practical impact, like what is like the pragmatic application. And then I a lot of times end up working backwards to thinking about, oh, this is like a methodological thing we need to do. We need to test for world models. We need to find ways to debias methods. And I think because AI is touching everything, that this is really the time to bring an interdisciplinary perspective. And I think one of the really challenging things about interdisciplinary research is that most of us are trained in one discipline. And when you start talking about another discipline, you sort of have like an accent. Like it's clear to people in that other field that like, oh, this person doesn't come from there. And it's not just talking, it's also about like thinking. It's tough to figure out like what are the interesting problems or the ways of thinking in that field. And so I think that like, something that I'd love to do, that I think there's been, more of work of this recently, but this is still like hasn't taken off to the extent that I hope it has, is to train like interdisciplinary thinkers in the areas I work in, and like AI and social scientists. There's been a lot more like now in econ PhD programs, a lot of the students are coming in really, really interested in AI. And I think that the more that we can get together people in the same room who, have AI as a background, have econ as a background, or sociology or other sort of sciences, so on and so forth, and talk to each other and learn about their problems, not just once, but over an extended period of time, I think is sort of something that I've, benefited a lot of. And I think that from obviously my biased perspective is what's going to be really useful going forward.
Right. But I think that something that stalls that or prevents that is that there's like so much friction that's introduced when you have that accent, like you said, and when you don't understand each other right from the get-go. And like I've worked with economists, like I've worked with computer scientists, and it's like it can be really fun, and it can also be kind of frustrating because like people do not understand each other. And sometimes the middle ground that you get to isn't necessarily better. I know that one of my literary theory grad seminars, and my professor was talking about how frustrated she was even with an interdisciplinary seminar within the humanities, because she was the problematics that we're all situated in are sometimes contradictory. And so all it ends up being is as an art historian or as a historian or as an archaeologist, whatever, I think this, and then it's just we're at this impasse. And I think that that can be the challenge of interdisciplinary research. And the benefit is that you learn something new and blah, 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 and it's kind of this hunky-dory situation. But I've definitely been in those rooms where it's I took a grad seminar that was co-taught by a computer scientist and basically an author, we have this discipline called literary arts. And I know that a lot of the grad students in that class were frustrated with the slow pace or they didn't understand things. And I think that I was actually having a great time because I had some background in neuroscience and I had some background working with LLMs. And so I was rocking out with the readings. I was this is awesome. Give me more Mar, in 1980, whatever. I love it. But it takes having a little bit of background in these other fields. So I think you're right. The point about yes, we need to train interdisciplinarily from the start. But I think seeing interdisciplinary research as a priori sexy or a priori beneficial is difficult.
Yeah, exactly. And I think what you're getting at is that there's a large activation energy. It's very, very beneficial once you become bilingual enough or bicultural enough, but it can be very, very challenging to kind of get there. And I think that more often than not, the way that people start is they're kind of thrown into the deep end. You're giving a talk to a bunch of senior people in another field who don't know anything about your field, and that can really kind of change your experience and color how you think about it. So I think for lack of a better phrase, there should be areas where not necessarily safe spaces, but areas where people can students can talk and just learn from each other without any expectations, without kinds of, oh, you said this word the wrong way. You said causal when you actually mean correlative. And I think setting these things up where people are invited to, make mistakes, where even the senior people are invited to make mistakes, because, even senior people, there's a lot of their own discipline and also other disciplines they don't know about, I think can set up things that are hopefully less, easier to get into.
Thank you. Can we talk about career? Because I feel this is the natural place to go next. So this is career, and on another podcast that you did, the interviewer said, I hope you can hear that I'm saying it as an acronym. So again, I will parrot that guy and I'll say I hope everyone understands that I'm saying this as an acronym. It's capital L caps career. You have a few areas in this lineage of kind of labor economics and foundation models. And this is really interesting to me because it's a methodologically interesting problem. You're taking questions that have been asked and somewhat answered for decades, which is wage gaps and just problems in labor economics, and why are there wage gaps, and why are there wage gaps based on gender and race and things like that. But you're doing this from a very different perspective methodologically. So what is this? What is career? Why are foundation models useful for economics and social sciences more broadly? This is a prediction model, so how are you treating the relationship between prediction and causality? Because you're not using standard causal inference econometrics methods here, but you're claiming that your results are better. So tell me why.
Yeah, great question. So I think for that, I guess I can start into how I started working on that, which was I had done a few projects in natural language processing in right around COVID or right after COVID, and I'd been working with these kinds of transformer models that are really good at taking sequences of objects and predicting the next variable. So language is the canonical example of this. A transformer, it takes a sentence, which we can think of as a sequence of words or really tokens, and predict the next word or the next token. So I'd done some work on this, and then I started talking to, I'd done work on this in the kind of NLP space, but I was very interested in kind of more applied problems, problems in the social sciences were ones that really excited me. So through my advisor, David Bly, I had talked to him about this, and he connected me to an economist, Susan Athey, a very well-known and accomplished economist at Stanford, who he had worked with before, who had already done amazing work at the intersection of machine learning and economics. And we sort of started chatting about problems that could be interesting. And so one problem that she had been thinking about for a bit, because she had been able to acquire various data sets, was a problem where you want to predict the next job that someone has in their career based on what you know about them so far, like their, where they are now, where they've been, what their education is, so on and so forth. And so I started working with her because I recognize this is a very similar kind of problem to a problem that I've been working on in NLP, in natural language processing, which was, can I predict, instead of the next word of a sequence of words, can I predict the next job in a sequence of jobs? And so a lot of the prior approaches to this problem from the economics sort of literature hadn't really used the fact that, all the jobs in a history to predict the next job. Instead, they have a property that we call a Markov property, that we say something like, your next job only depends on your current job, or maybe your past two jobs. But the challenge of including more, even though if we think they might be informative, is that it's just very, job careers get very, very complicated as you sort of add more and more. There are exponentially many job career paths you can have. And so the transformer is one kind of architecture that tries to get around this by kind of compressing information, by saying, some jobs are more similar to another, and I'm going to treat these as kind of more similar, so really we can share and pool information. So this was the motivation. We worked on adapting transformer models to model next jobs instead of next words. We had to make a few modifications to get them to work. One was, for example, people tend to keep their jobs year after year, whereas in language, you typically never have the same word repeat twice consecutively in a sentence. So we changed some things around that. And then the sort of big thing that we changed was, we, in the United States at least, a lot of the data sets that economists use to study labor markets are these very small survey data sets, these longitudinal surveys. The two famous ones are called PSID, the Panel Study of Income Dynamics, I think, or NLSY, which is the National Longitudinal Survey of Youth. And essentially, these involve surveyors following the same cohort of workers and going to them every year or every other year and asking, hey, what's your job now? What's your wage? So on and so forth. And so you get all these really detailed trajectories for each person in the survey. But the problem is that there are not that many people. There are maybe 4,000 or 5,000 people in a survey, let's say. And these transformer models really do best when they're trained on tons and tons of data sets, millions, billions, in the case of large language models, trillions of tokens. So something that we did to get around this was we took a very large data set of resumes and trained the model first on those and showed that we could then adapt the model to predict jobs very well in the surveys. And there they were able to make, very good predictions of someone's, next job or next wage and so on and so forth. So, these were the results. And I would, present these results sometimes. And a question that I kept getting from economists was, your model can predict very well, but what can it tell us about the workforce? We don't really, maybe predictions are great. Maybe in some places we do care about predictions, but can we use these predictions for more than just predicting someone's next job? So from there, we started working on taking a model that can make good predictions to not predict what job someone will have, but to tell us something about the workforce. And the problem that we were interested in was the gender wage gap, which, like you said, has been a problem that has been studied for a very, very long time. And one kind of strategy that labor economists use and sociologists and other economists use to study the gender wage gap is to say, let's not only see what's the difference in wages between, males and females in a population, but let's control for variables. And so that essentially says, there are different jobs that males and females tend to have more than the other. And so conditioning on the kinds of jobs that males have or females tend to have can, quote unquote, explain this gender wage gap. And so there's been a lot of work that tries to say, what is a gender wage gap, let's say, among people who have the same job, or among people who have the same industry or have the same years of experience. So one thing that we wanted to do was say, what is the gender wage gap for career histories, for two people who've had the same careers? What happens when we do gender wage gaps adjusting for those? And so this essentially, the sort of career model is is sort of adept at doing this because what it really does is it takes someone's career trajectory and summarizes it with, just essentially like a sequence of numbers. But the challenge is that like vector of numbers that is used to summarize career trajectories is really good at one thing, which is making predictions. But if you want to do this kind of adjustment, which is not a causal quantity because there's no causal interpretation, but it looks like a causal quantity mathematically in the sense that it's really a difference in average predictions and not just, you want to make sure that it's well calibrated for both males and for females instead of just good at individual predictions. We had to do some work to try to, adjust it to explain these things. So, and that's, I won't go into detail about that because that's probably going to get a little bit hairy.
Okay, so do you have it like, I can cut this out if it doesn't work, but I feel like I've never actually fully grasped where did you come up with a different answer than, say, like Claudia Golden, who won a Nobel Prize for her work on the gender wage gap. And she found that the gender wage gap it's all about parenthood or motherhood penalties in the sense that, if you and I, if Keyon and Talia go on for the same job interview and we get the same job, we're not going to be paid different. We're going to be paid the same. But then in 5 or 10 years, you're not having the baby, I'm having the baby. And then I drop out of the workforce or I take a more flexible job that gives me less pay but more flexible hours. And then I make less money. And that compounds over time. And one is exponential and one blah, 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 convex, concave, whatever. Okay. Yeah. So that is the dumb summary of her work.
No, that's a great summary. Yeah, and I would say it sort of complements that. Because we weren't looking at things like the motherhood penalty explicitly, but one nice thing about setting trajectories is that you could compare, people beginning of their career and end of career. And so what we found is that if you look, and this has been found by other, great economic papers as well, is that if you have a fixed cohort and look at the gender wage gap among that cohort, right when they start or a few years after they start versus 10, 15, 20 years into the future, the gender wage gap will expand, pretty consistently across those years among workers who keep working in both of those cohorts. And, one of the most natural interpretations is what you suggested, this motherhood penalty.
Okay, got you. And then so we're turning to kind of the question of again, the methods that you're using and the difference between prediction and causality. And you characterize this whole project of career in one paper as a debiasing. So you're using these kind of debiasing methods to get at things that can quote unquote estimate causal effects. But what does it mean to estimate causal effects rather than do just regular causal inference? And then also, I think more broadly, I'm interested in kind of the fact of this project, because I think that your work points to a trend in data science and economics research, which is that you're using fine-tuned models to answer questions rather than using these standard regressions and things that have been used for decades. And that's interesting for a lot of reasons, but I'm kind of interested in the fact of the project and its methods.
So what you're getting at kind of gets at this tension, which is machine learning, predictive models are very good at making predictions in a kind of average sense. So in the context of career, we were able to make very good predictions for what someone's, let's say, wage will be on an average sense. That means that for every individual, you look at the predicted wage minus the actual wage, you square it, and you take an average. And that if that number is small, that's a pretty good thing. So with career, what we want is really an estimate for everyone in the population if you're making predictives. It's every person has a number that says this is a prediction for wage. The gender wage gap is a different story. The gender wage gap is not a number for every individual. It's one single number for your entire workforce, for your entire population. You want a number, which is what is the average difference in wage between females and males who have the same career history. And so it turns out mathematically that you can do very well or reasonably well on these individual point-wise predictions, but still do very poorly if you take the difference between these two averages. So I can in an average sense get pretty close accuracy to how a male would get paid for a certain job and how a female with the same characteristics would be paid individually. But small errors in these estimates could result in large errors overall. And so this was the goal of debiasing, that in most machine learning techniques, the goal isn't to do estimation. The goal isn't to get a single number. I want a prediction for every word in my thing. I don't really care about a kind of single, I'm not really using it to get a single number of, what are the kinds of words I write. I just sort of, get predictions, and if they're most of the time, great. And so what we had to do was rather than just plugging in these estimates that are, really good individually, this is where we had to sort of think about debiasing, which was how can we debias the methods that are maybe good at predicting, A and are good at predicting B, but debias them so that their A minus B prediction is better than what we would otherwise think.
Got you. Okay. And is this, again, so do you think that it is kind of like incumbent upon all the social sciences to do more of this work with foundation models and with prediction? Like, do you think it is incumbent upon us to think about prediction rather than causality all the time? Causality is very fraught and complicated mathematically always, and like to formalize questions of causality it's vexed a lot of people for forever. But is it just like is it not only the easy way out but also the more accurate way out to kind of think about prediction?
Yeah, it's a great question. Like, I do think that it's important for both fields, like, both the computer science fields and kind of the more social science fields to really understand this like perspective that the other field has. And so for the social sciences, like you say, there's been a lot of work on causality, and there has been, less work thinking about what we can do in terms of predictions. That is changing, though. And I think that there has been, some really fantastic, interesting work thinking about how can we weave in prediction, not even into like causal estimation, just prediction in its own right. So, for example, Matt Salganik, he's a sociologist at Princeton who's been doing some like really, really interesting work on this. Back, maybe 5-6 years ago, he, along with many collaborators, they ran a data challenge where they had collected survey data that follows families and children over the course of the first few years of their children's lives. And they hosted a challenge to see how well people could predict how the children would be doing a few years later. And the key thing they did is they collected this data privately, and they didn't release their the future data, so that they had all these teams compete that really didn't have access to the data. They couldn't look ahead. And that was a sort of challenge that was like dedicated to seeing how predictable are life outcomes? Like, how well can we actually predict what someone's GPA is using the best predictive methods that are available to a large group of researchers who are incentivized to get the right predictions because of the data challenge. So that's, really interesting work. And, spoiler alert, they found that life trajectories really weren't that predictable. But so something that Matt has been doing now that, I've been working with him a little bit, and again, Matt has been leading a large-scale collaboration, is this was sort of in the pre-foundation model days. And Matt and, a large group of social scientists and computer scientists and other collaborators have been working on taking foundation models like LLMs and fine-tuning them on very kind of large-scale administrative data sets that we see that countries in Europe collect, for example, to see are life outcomes more predictable once we have bigger and better models. So, that's one example. But I think, like, in general, I think the predictive perspective is definitely an important perspective for social scientists to think about because, like you say, causality is fraught. It rests on untestable assumptions versus in prediction, there are some assumptions, but they're at least different, and maybe in some settings that they're going to be more realistic. Like another person, a group of people who's been doing this is the sort of like prediction policy work. This is led by people like, Sundal Mullainathan, who I worked with on the sort of world model paper, which is saying, if we in scenarios where people's decisions are based on the predictions of algorithms, how can we make sense of how good those algorithms are, how good those people are, which again is sort of another perspective of prediction and incorporating it into the social sciences.
Yeah, and also I think, causal inference rests on counterfactuals, which are hard to get at. And so there are a lot of problems that are like super primed for thinking about causal inference, and then some that aren't because it's really hard to get at the counterfactual. And sometimes data sets are small, and yeah.
Yeah, that's the thing about prediction is that we don't have to test counterfactuals. You could argue, and it's actually has been argued, I think, quite convincingly by people like David Donahoe, who's a statistician at Stanford, who said that one of the real reasons machine learning has been successful over the past 10, 15, 20 years is because we had very, very quick ways to validate how good our model was, which was we could make predictions and see how accurate those predictions were. And that is an immediate test of how good is this predictive model. Causality doesn't really have something like that because you need to, maybe you have it in like simulation studies, but you don't really get to see counterfactuals most of the time, if ever. Whereas machine learning, you have in most ways a like single button you can press that can instantly tell you if tweak A is better than tweak B for the goal of making prediction. And it's that kind of very quickness and rapid feedback that has led to the amazing progress we've seen in machine learning.
So when I was going through your papers and your research, I was kind of noticing this like chiasmatic structure creeping up, or like reversal, where you're using AI to study humans on the one hand, but then also using humans to study AI on the other. And I was wondering if you could touch on that chiasmatic structure or reversal.
Yeah, that's a great question. So like, in my PhD, I had a lot of I went a lot in that one direction, which was, how can we use transformers, other models in AI to study human behavior? And the sort of nice thing about doing a postdoc, which, I recommend to everyone who is interested in academia or doing PhDs, even if you're not doing a PhD, do a postdoc, is that so one of the nice things is that I was able to think about new questions. And one such question I started thinking about was, instead of using AI to help us understand the social sciences a little bit better, can we use ideas from the social sciences and behavioral sciences to help us improve AI models? So I've worked on this, a little bit. Like one project that I worked on that I thought, was a pretty fun project at the time was trying to think about how we evaluate LLMs beyond just how they perform on benchmarks, but about thinking about whether people can figure out how to use them. So what I mean by that is, like, let's say that like I ask you a question about quantum mechanics and you answer that question correctly. Then I will, assume okay, like Talia, like really knows about quantum mechanics, like probably also knows a lot about physics and math. I have no idea if you know what are the good Mexican restaurants in Kansas City. So maybe I won't ask about those, but I'll definitely like keep asking you questions about, physics and math and, other things that I think are implied by that. So we do the same thing for LLMs. Like what I do, for example, is when an LLM comes out, I will play with it a little bit. I'll ask it a few questions, and then I will like form my own mental model of like, oh, this answered these 8 questions right and these 3 questions wrong. I think it's going to be good at these sort of things. I think it's going to be bad at these sort of things. And so something that I worked on with Sanal Nathan and Ashish Ramachan was trying to model this sort of as a kind of human generalization function, which was after I see X, I see an LM answer X, Y, Z correctly, how do I assume it'll perform on A, B, C? And the reason this matters is that it sort of suggests an important kind of alignment that I think a lot of the common ways to evaluate and benchmark LLMs are overlooking, which is if we're using these sort of ideas about where LLMs will do good and bad to use these actual LLMs, what matters is not just what's the best LLM on average, what answers the most questions on average, but which LLM is the one that allows me to make the most accurate inferences about what it's good at and what it's bad at after a short number of interactions. So if I can like crack the LLM, if it aligns my mental model, that's going to be far more useful than one that maybe is even slightly more accurate, but doesn't match my mental model at all because I won't figure out where to use it and not use it.
Tell me this is relevant or if it's not, but I think that I saw some like stupid LinkedIn post and it was like breaking news. People use multiple LLMs in their day-to-day life. Like they're not only doing Claude or only doing OpenAI, like it's both and Gemini. Do you think that that's indicative of your research that people are thinking about their human generalization function and their best use case?
Yeah, it's a perfect example. Like this is saying that like the reason that people are using OpenAI, ChatGPT for one thing and Claude for another thing is they're sort of saying like in their head they must be thinking, oh, I think this is the kind of thing OpenAI or ChatGPT is going to be good at, so I'm going to use it. I think this is the kind of thing that Claude is going to be good at, so I'm going to use it for that. So that is like a human generalization function that they're using. I do this too. Like I use Claude for a lot of my coding. I think it's fantastic for coding. I also use it to like help with writing every now and then. But for ChatGPT, I'll use ChatGPT for summarization. I find it better at summarizing, or at least it summarizes papers in the way that I kind of like, in a way that's more accessible than Claude. So yeah, and then the question is like, these are human generalization functions. How accurate are they? I think is a really interesting question.
Right. Yeah. I also, well, I mean, like, I don't know how to code at all, but I actually do know how to code because I can vibe code now.
Yeah.
So never had to learn to code. Psych. What's good? And I use, well, I guess when I was doing more of that, I was using Claude. But that's different than using models for different, like, political reasons. Like, I don't want to support, this company or that. I mean, there is an element, I think, that there's like a branding of these models that I think shouldn't be overlooked. Like, Claude has a brand to it, that it's safe and it's ethical and whatever, and OpenAI doesn't really care about that and blah, blah, blah. And Gemini often sucks, so then there's that. And that's not necessarily a brand, but as far as I can tell, it's part of the brand at this point. Okay, great. So, Keyon, I know that you really like movies, and I was...
Wait, how do you know this?
How do I know this? I'll cut it out. Wait, okay, no, I really actually want to ask about this. So I know that you like movies, and I wanted to know, because sometimes people tend to, glean intellectual inspiration from these sort of like more aesthetic objects that they're interested in. And I was wondering if that's something that you resonate with, and if not, it'll be gone from the world. So yeah, cinema.
Yeah, yeah, it's a great question. I guess like the closest thing to that, like the closest thing to a response, and feel free to use this, is I watch a lot of movies. My favorite filmmaker is an American documentarian who actually passed away earlier this year. His name was Frederick Wiseman. He's a really interesting career. He started as a law professor, I believe, or lawyer, and started making documentaries, I think, in his either late 30s or 40s. And he was very prolific. He'd make like a new documentary every year. And the style of his documentary was very interesting. It was a documentary technically, but he would typically go to an institution and he would film, and there wouldn't be like talking heads. Like there was never like, someone has an interview, and there weren't like most of the time there weren't characters who would show up in multiple scenes, but he would show these like vignettes of typically like institutions, and you would just, as in your audience, you would just watch them and just like notice things. And it's like, it's a really different kind of movie experience because you're very immersed. You have to observe. You're not explicitly being told how to think, but you're actually very implicitly being told how to think, or not how to think, but like he's really, most of the times he's making these like very implicit points. So like, examples of the kinds of topics he has is he has a like documentary about City Hall in Boston, where he just, went to City Hall and filmed there. He has a documentary about Central Park, about the like New York Public Library, about Jackson Heights, about the police in some town, and like hospitals. So he like really goes these places and just like immerses yourself, and the goal is to try to not understand, but like just like really get a sense of how things work. So like the best analogy I have is I've done a few internships, and I feel like after the first week of an internship, you sort of like, oh, like this is the kind of place that I'm in. Like this is the culture, this is how it clicks, these are the kinds of rules. When I watch a Fred Wiseman documentary, I'm like, oh yeah, this is like, I never thought about how like Central Park is designed, or like what the programming looks like at the New York Public Library, or at like, UC Berkeley has a documentary that like has, filmed a 4-hour thing at Berkeley which has a bunch of like meetings with the chancellor. And so I guess like, I bring this up because I think that, if I can, stretch and make this comparison, the thing that I really, really love is that he is, observing. He's like he embeds himself into these institutions, and very like doesn't tell you how to think, but very kind of like implicitly in his like editing choices, you can sort of tell that he's making a point. So like he has one movie about like a high school, and like very subtly, like the very first shot of the high school it's filmed kind of like the outside of the building, and the way it's filmed kind of looks like a kind of like insane asylum, or like a very like unhospitable place. And he's sort of like trying to say, like make a point about like this is what like schools are doing to students at the time. And so I think like, one part of that I think is like a good goal for researchers. So like, embed yourself somewhere, like be really, really familiar with it, and express things like as they are, and they like do things in like a very like show things how they are, but also to have a like kind of like research conclusion that is sort of like the natural conclusion that any reasonable person could have after embedding themselves into these places. So, I don't know if the research analogy is there. I need to keep thinking about it. But I just wanted to plug Fred Wiseman, who I think all his movies are on Canopy. So if you have a library card, you can watch them, and they're usually like 3 to 4 hour documentaries. But I highly recommend them.
Okay, well, first off, thank you so much for that. No, that was fascinating. Yeah, I think maybe what you're pointing to, this is how I'll frame it, is that documentaries are so much more fictionalized than we realize often, right? Like Talking Heads and the way that you edit and the music that happens, like it is so narrativized, and like the trick of the documentary is to make you think that it's not, right? And maybe what you're saying is that this guy is sort of like pushing the limit on realism or something.
Yeah.
Or he's like trying to get more to that. But you're actually, it just occurred to me when you were talking, you're the second person that's come on that's been like really interested in movies. I interviewed Justin Koo at MIT in the philosophy department, and he actually has a podcast like on movies.
Oh, wow.
Like he's a philosophy professor, but he has a podcast where he just discusses movies, like with philosophers sometimes, but I think like most of the time just like co-hosts with his wife. But but you have two very different like views on it, because he's really interested in movies for like the philosophical questions that they ask and answer, and I think you're really interested in movies to think about like just like construction, and then like how are you making a point with editing, with the shots that you're doing. I mean, like all this stuff has been studied endlessly, but it's like fascinating. So thank you for that answer.
Yeah, I like that insight.
Okay, cool. Keyon Vafa, thank you so much for coming on Tomato Tomato today. It's been so fun having you on.
Thank you very much. I really love chatting.
Thank you so much for listening to Tomato Tomato. I have been your host, Talia Sherman, and that was the adroit Keyon Vafa. Check out his website for further information about his research and what he's up to next. You can also head to YouTube to watch select clips with video and audio from all my episodes. You can also rate, review, subscribe, and forward the podcast to people you know or don't know. Literally put in a random number into your phone and send them the link to this podcast. I'm sure people will appreciate hearing from an unknown number with an unfamiliar area code. And I will speak to you next time. Bye.